Hello everyone. Today I will be presenting the topic Scaling with NoSQL, why modern systems need NoSQL databases. In this session, we will explore the limitations of traditional relational databases and understand why modern large-scale applications increasingly rely on NoSQL systems for performance, scalability, and flexibility. Why NoSQL emerged? Let's begin with why NoSQL databases emerged. Traditional relational databases such as MySQL, Oracle, and PostgreSQL work well for smaller, structured applications, but they start to struggle when systems grow to an internet scale. The challenges include massive data growth, handling millions of concurrent users, high cost of vertical scaling, performance limitations caused by strict ACID compliance, heavy operations such as complex joins and stored procedures. Companies like Google, Amazon, and Facebook pushed these systems to their limits. Their needs for global user traffic, huge data sets, and real-time performance made it clear that a new approach was required, and that's what led to the rise of NoSQL. What is NoSQL? So, what exactly is NoSQL? NoSQL refers to a broad category of non-relational databases designed for horizontal scalability, distributed architecture, and high availability. Some of their key characteristics are they do not primarily rely on SQL, they support flexible or schema-less designs, they are built to run in a distributed environment, they make certain trade-offs to scale efficiently, and they handle massive datasets with global traffic. Technologies like Google File System, MapReduce, Bigtable, and Amazon Dynamo heavily influenced today's NoSQL systems. The CAP theorem. One of the fundamental concepts behind NoSQL design is the CAP theorem, proposed by Eric Brewer. It states that in a distributed system, you can only guarantee 2 out of 3 properties at the same time. Consistency, all nodes see the same data. Availability, every request receives a response. Partition tolerance, the system continues to work even if the network is unreliable. In simple terms, you must pick two. No NoSQL system can fully provide all three. So each database chooses different trade-offs based on its goals.
Hello, Assalamu alaikum. I am Shadi Desnath. So from here I will continue. So let's discuss about the eventual consistency. So we know that some NoSQL databases prioritize availability by allowing temporary differences between nodes. This is called eventual consistency. It writes paired asynchronously. Different node may return different version for a while, but eventually the system become consistent. So basically, this model is used in systems like Dynamo and Cassandra. So let's go to the next topic, handling conflict in NoSQL. When two clients update the data at the same time, NoSQL use several conflict resolution strategies. These include last write wins, which is simple but may cause data loss. The next is client-side merge, where all versions are returned and the client resolve them, like Amazon card. And the last one is background repair, such as Cassandra repair, which automatically synchronizes data. So let's go to the next topic, quorum consistency. So what quorum consistency do? It basically improves safety by requiring a majority of replicas to confirm operations. A quorum write means most replicas acknowledge the write, and a quorum read means the client read from the majority. So this helps ensure the newest value is returned without completely sacrificing the availability. So that's it. Thank you.
Hello everyone, moving to our first example of scaling, let's look at the MongoDB, which is the alternate approach of NoSQL. MongoDB chooses a very specific trade-off. Unlike system where data is everywhere at once in Mongo, each piece of data belongs to one primary node supported by replicacy. The strength here is automatic failover. If the primary node goes down, a new one is elected very quickly, ensuring the system startup. However, you need to be aware that because replication is asynchronous. Now let's compare that to Cassandra. Cassandra is the combination of Bigtable and Dynamo, which is that Google's Bigtable and Amazon's Dynamo. The key differentiator is here that is a peer-to-peer cluster. This means here is no single point of failure. Automatic data partitioning, where is that it takes your row key, hashes it, and assign it to the responsible nodes automatically. This gives you a wide column data model with a flexible schema. But remember, because of this structure, you don't get the complex join you might to be using MySQL. So to wrap up the NoSQL landscape, let's weight the pros and cons of NoSQL. On the advantage side, the benefits are clear. You get massive horizontal scalability, high availability, flexible schema, self-healing, and automated clustering. And this is example of Cassandra. And here is this comes with the challenge. You often sacrifice immediate consistency for eventual consistency. You have limited query power compared to the traditional SQL, and honestly, the data modeling requires a completely different mindset. It often requires deep internal knowledge to turn correctly. Ultimately, NoSQL is a powerful tool for skill provide and you understand. Thank you very much for your time. I am happy to take any questions you might have. Thank you.